Okay, good morning. I'm very pleased and honored to introduce my colleague and friends, Paolo Bonato. And Paolo is graduated in the Polytechnic of Turin in Italy. And after that, he's spending research and time in Boston University for several years, and is now director in the Spaulding Rehabilitation Hospital in Harvard Medical School for what concerns rehabilitation. Paolo is one of the world-leading experts into rehabilitation area, in particular in the wearable solution for that. So again, it is my pleasure to introduce Paolo to the audience and to see what he's going to tell us about his perspective in the wearable technology and rehabilitation. Please.
Thank you very much. Is the mic okay? Everybody can hear? Is everybody awake? Yeah? Raise your hand if you're awake. Okay. Okay, so this should be off. Well, thank you very much for the nice introduction. I hope this is not too loud. Italians tend to be loud, but not this much. Okay, this is okay. Well, thank you very much for the nice introduction, Danilo. And thank you, Sergio, for the invitation. It's really a pleasure being here. So what I'm going to do is in the next 40 minutes, is that okay if I speak 40 minutes? I'm going to give you an introduction about applications of wearable technology in rehabilitation. We were just speaking this morning with a colleague, and he was saying, well, rehabilitation is coming up as a big application of wearable technology. I'm not sure whether this is just the case because I come to this conference and I keep talking about applications on rehabilitation, or it's really true that because of the aging population, the incidence of neurological conditions, this is in long-term conditions that are associated with these diseases. This is actually becoming quite an important area of application of wearable technology. The applications that we have an interest for, applications in which you have to monitor movement patterns in people with mobility limiting conditions. This is just a very simple example of a patient tested in what we call the apartment simulation, let's just call it this way for simplicity's sake, in which we do observations of patients before they move back home, so at the time of discharge, essentially. And this is all videotapes that we took by utilizing ambulatory technology, where we were attempting to monitor activities of daily living. And what we do essentially in my laboratory is to try to capture movement patterns that are associated with these conditions and see how interventions are affecting functional capabilities, so the ability of individuals of performing activities of daily living, as well as level of impairments which are more structural type of problems in these patients. The lab is set up to do evaluations in the clinical setting utilizing an infrared camera system. This is a very standard type of technology. And we do provide also standard clinical evaluations, but this is all concentrated, or this is all done in a clinical setting. And what you get are schematic representations of this type and all the kinematics and kinetics associated with it. So these are things that I believe most of the people are familiar with. But if you're not, just very simply stated, we are describing the kinematics and kinetics of movement of individuals in a clinical setting and associating the characteristics of these movement patterns to conditions that are this very large category of mobility limiting conditions. However, what you observe in a laboratory setting is only a very small portion of the picture that you are interested into. And the main focus of the intervention is obviously not the one of improving performance in a laboratory setting, but rather to have an effect in the field. And so lots of us have been looking into in the past into utilizing sensing technology to capture this type of phenomena in the home and community settings. But unfortunately, the technology that was available until a few years ago was not really suitable to do field monitoring. And I like to show this picture of former student, a PhD student who worked with us. And you know that only PhD students are going to do this. This is obviously not something that's suitable for patients. We were exploring at that point in time the potential of sensing technology to complement what is called the FEAM assessment, which is an assessment of functional capability in patients. We want to know whether patients can live independently through this type of assessment. That's the type of information that we try to gather. And we did use, in that case, a combination of accelerometers and EMG electrodes to complement this type of assessment, essentially identifying activities that are in the categories of these FEAM evaluations. But obviously this is not possible with traditional sensing technology. So lots of us, a few years ago, when wearable started coming up as a potential development of this technology, and the program promoted by Andreas initially took off. We look at wearable as a possibility to achieve this objective of monitoring what happens to patients when they go back to the home and community settings. And really my group, I would dare say, is not a bias toward one technology versus the other. As everybody knows, there are two major technological developments, the one in e-textile and the one in wireless technology. The way we see things is very much from the application point of view, and therefore we tend to use a combination of these two technologies. And through the talk you would appreciate that we actually have projects in which we truly combine the two as opposed to try to utilize one or the other. The bad news with this type of technology is that unfortunately the off-the-shelf components are really not suitable to do what we are interested in doing, and therefore we've been doing some of the development on our own. These are wireless components that we developed together with Matt Welch at the Division of Engineering and Applied Sciences. Matt is an expert in firmware development. This is a unit, a wrist unit with a 3-axle accelerometers and Zigbee. That further was developed by an R&D group that belongs to Intel that is in Cambridge, Massachusetts, that we work very closely with, which eventually led to the Shimmer platform, what is the Mobius initiatives, the group in Dublin led by Terry DeShong. The same if you look at the off-the-shelf e-textile type of solution. We have a number of companies in the US that have an interest in this area, but we have to come across the ocean and work with Danilo's group to actually being able to rely on hardware that's thoroughly suitable for the type of applications that we have an interest for. Lately we have mostly focused on the use of these data glove that's Danilo's technology, where through sort of printing of conductive elastomers on top of Lycra, we can actually monitor movements of the hand. The concept that we want to implement, it's really summarized by this picture from Enterprise, which is, you might be familiar with it or not, it's kind of the Star Trek series. And I like often to use this slide. From one side, opening that this is going to wake up the audience, but also from the other end, because I think that it does summarize what we're trying to achieve. So what you see in that picture is actually the physician who sees patients in this TV series that tells you about this group of people exploring space. And so they are on this mission in the galaxy, and they have, obviously they're not in perfect health all the time, and so from time to time they need to go to sick bay where the doctor diagnoses them by utilizing this handheld device that provides